In continuation with chapter number 2, units and measurement, our next topic is conversion of one system of units to other system of unit. Now see, there are some steps which we have to follow to convert one system to the other system of units. That is, first the unit is given to us and we have to find that this unit belongs to which physical quantity. So first is find its physical quantity, then formula of that physical quantity, find dimension, write powers of dimensions, that is, let A, B and C. Then as we know that physical quantity is given by number and its unit, that is, we can express one system is equal to another system. Take this number that is on the right hand side, take this number as unknown quantity, which you have to find, and after that write in the form of dimensions m1 by m2 A, L1 by L2 B and T1 by T2 C. These m1, L1, T1 are the dimensions of one system, and m2, L2, T2 are the dimensions of other system. Let's see by one example. Let us suppose we have to convert, the question is we have to convert 1 joule into, number is not given, into how many ergs. So first of all, by the formula, by these steps we can see that joule is the unit of energy. So our physical quantity is energy, and energy can have many formulas. It can be potential energy, kinetic energy, it can be in the form of work. So let us take it as potential energy. Its formula is given as mgh, and here mass can be written as kilogram in SI system. Acceleration due to gravity is given as, its unit is meter per second square, and height is given as meter. That is, we can write it is kilogram meter square per second square. So its dimension will be, dimensions should be enclosed in a square brackets, and kilogram is given by m raised to the power 1. Here meter, it is meter square, that is length square, second square, that is time raised to the power minus 2. Now here we can see that A is equal to 1, B is equal to 2 and C is equal to minus 2. This will be same for both the systems. Now here we have calculated the dimension. We can remember only some dimensions for each and every physical quantity. It is not possible to remember all the dimensions, so we must know the formula, and by this we will derive its dimension formula. So here this is our dimension, that is m1 L2 T minus 2, where A is 1, B is 2 and C is minus 2. Now see, here we can divide in these physical quantity, that is energy, in two system of units. One, we know that it is joule. Joule is the SI unit of energy. So we can write it as SI system, or Earth is the unit of energy in C.G.S system. In SI system, mass is given in kilogram, length is in meter, and time is in second. Here, mass in C.G.S system is in gram, length in centimeter, time in second. So, one step we have to follow, that what we have done, we have derived this equation that N2 is equal to N1, M1 upon M2 raised to the power A, L1 upon L2 raised to the power B, and T1 by T2 raised to the power C. So here the dimensions of both the systems of units should be same. Either you convert this gram into kilogram or convert this kilogram into gram. One and the same answer will achieve. That is, let us convert this gram into kilogram. That is 10 raised to the power minus 3 kilogram, 10 raised to the power minus 2 meter, and here it is 1 second. Now substitute these values. Now they are equal: kilogram, meter and second. Now substitute these values in this equation. We know that N1 is 1 joule because we are treating it as N1 U1 equal to N2 U2. Now see, substitute these values, we will get N2 is equal to N1 is 1, M1 is 1 kg by 10 raised to the power minus 3 kg. Kg and kg will cancel out, and raised to the power A, that is 1. L1 is 1 meter, L2 is 10 raised to the power minus 2 meter raised to the power 2. T1 is 1 second and T2 is 1 second raised to the power C, that is minus 2. We are getting here, when we will take it in numerator, then N2 is equal to 10 raised to the power 3 into 10 raised to the power 2 whole square, that is 10 raised to the power 4. We get N2 is equal to 10 raised to the power 7. That is 1 joule is equal to 10 raised to the power 7 earths. Now see, in the question anything can be given to you. Let the number should not be only one, you're always one. It can be any value, or you have to find the value equal to that, and you can have to convert joule into ergs or ergs into joule. Anything can be given in the question, but you have to follow these steps in the question. You have to find the equation and find the formula, then dimensions, then the powers. After that, find the SI and C.G.S systems, make them equal, substitute these value in the equations, and then find value of N2. After substituting in the equation, we get the result. Now see another example. If we want to convert it, the question is, let us suppose 10 raised to the power 9 ergs is given, and you have to convert ergs into joule. So now we know that ergs is a unit of energy, and dimension of energy is m1 L2 T minus 2. So here A is equal to 1, B is equal to 2, and C is equal to minus 2. Now from this equation, just substitutes the value, substitute all these. So N2 is the unknown term, N1 is given to us 10 raised to the power 9. Here M1 by L1 raised to the power 1, that is A, L1 by L2 raised to the power 2, T1 by T2 raised to the power C, that is minus 2. Now see, just find the system. Here C.G.S system is given. In SI we have to find. In C.G.S, mass is in gram, M2 is in, that is L2 is in, L1 is in centimeter, and time is in second. M2 is in kilogram, L1 is in meter, time is in second. Now we can convert this gram into kilogram or kilogram into gram, one and the same thing. So here I am converting kilogram into gram, that is kilogram is equal to 10 raised to the power 3 gram. Meter is 10 raised to the power 2 centimeter, and second is 1 second. Substitute all these values, we get 10 raised to the power 9. M1 is 1 gram upon 10 raised to the power 3 grams raised to the power 1, and L1 is 1 centimeter by 10 raised to the power 2 centimeter. Power is 2. T1 is 1, T2 is also 1. Power is C raised to the power, C is equals to minus 2. Now we can see that 10 raised to the power 9 into 10 raised to the power 3 into 1 by 10 raised to the power 4. So we can see that it is equal to 10 raised to the power 9 minus 7 equal to 10 raised to the power 2. That is N2 is equal to 10 raised to the power 2. It means that 10 raised to the power 9 ergs is equal to 10 raised to the power 2 joules. Similarly, you can see that in this question I have converted kilogram into gram. Now I am converting this gram into kilogram. So 1 gram is equal to 10 raised to the power minus 3 kilogram. I can do in this way also, and this is in SI system only. Now we will get one and the same thing. Here 1 gram is equal to 10 raised to the power minus 3 kilogram. Centimeter can be written as in meter, that is 10 raised to the power minus 2 meter, and 1 second. So substitute the values here. What we will get? It is 10 raised to the power 9. M1 is 10 raised to the power minus 3 kilogram by 1 kilogram raised to the power 1. Now L1 is 10 raised to the power minus 2 by 1 meter, and the value is 2. Here 1 second by 1 second. Power is minus 2. 10 raised to the power 9 into 10 raised to the power minus 3, 10 raised to the power minus 4. So here value will be 10 raised to the power 9 minus 7. It is equal to 10 raised to the power 2 joule. One and the same thing. So I hope you understand the method. We can also derive or convert any system like that if it is given in the question that convert 1 Newton into dyne. Now here we know that Newton is a unit of force, and the formula of force is, here its dimension is m1 l1 t minus 2, but if it is not remembered to you, then you can find it with the help of a formula. So force is equal to mass into acceleration. Mass into acceleration. Here the unit of mass is kg and acceleration is meter per second square. So here we know that kilogram can be written as m1, that is it is raised to the power 1, meter is l1, and time is t raised to the power minus 2. So here the dimension is m1 l1 t minus 2. Now its SI system values are given to us, and we have to find, or we have to convert it into C.G.S system. So here m1 is in kilogram, l1 is in centimeter, and t1 is in seconds. m2, l2, t2, m2 is in gram, l2 is in centimeter, t2 is in second. Now make a equation here, as we know that the dimension is this. So the value of ABCD, ABC is here 1, B is 1, C is minus 2. Equation is N2 is equal to M1 by M2 by A power A, L1 by L2 raised to the power B, and T1 by T2 raised to the power C. Substitute all these values. N2, N1 is 1 here, M1 is kg. Now first of all make them equal, make the units equal. So here I am taking this as 10 raised to the power minus 3 gram, 10 raised to the power 3 gram, and 10 raised to the power 2 meter. No, it's kilogram. So I am converting into gram. So that is 10 raised to the power minus 3 gram and 10 raised to the power minus 2 meter, and it can be written as 1 second. Now substitute the values. M1 is here 10 raised to the power minus 3 and gram 1 gram. A is 1. Now L1 is here 10 raised to the power minus 2 meter equal to, no, here, wait. What we have done, here it is already in meter, kilogram, meter, and I am converting it into centimeter. Yes. So write it as centimeter. Now the equations are same. Here it is kilogram, meter, second, gram, centimeter, second. Now 10 raised to the power minus 2 centimeter by 1 centimeter. Power is 1. T1 is 1 second, 1 second. Power is minus 2. Now solve it. 10 raised to the power minus 3 into 10 raised to the power minus 2. And 2 is equal to kilogram, gram, it is equal to 10 raised to the power minus 5 dyne. Now something is, we are missing something in this question. Here kilogram, I have converted kilogram, meter, second, 10 raised to the power minus 3. No, 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 no. 1 kg is given as 1000 gram. That is 10 raised to the power 3. Here we have mistaken. So here 10 raised to the 3 gram, 10 raised to the power 2 centimeter and 1 second. So here power will not come. This minus sign will not come. And the answer is 10 raised to the power 3 centimeter, 10 raised to the 3 gram, 10 raised to the power 2 and 1. That is 10 raised to the power 5 dyne. So this is the way N2 is equals to 10 raised to the 5 dyne. Here also we can write, we can convert it into kilogram. That is, just write M1 is given to you in kilometer, meter and second. Now convert this gram into kilogram. This is gram, centimeter and second. Now convert it into kilogram. 10 raised to the power minus 3 kg. And M2 is this. L2 is 10 raised to the power minus 2 meter. And T2 is 1 second. Now, it is in kg. And we have converted it into kg here, M2. Now, substitute these values in this equation. What we will get? Here, N2 is equal to, N1 is 1, M1 is 1 kg, M2 is 10 raised to the power minus 3 kg, raised to the power 1. L1 is 1 meter by 10 raised to the power minus 2 meter, raised to the power 1. And 1 second by 1 second raised to the power minus 2. Now it will be equal to 10 raised to the power 3 into 10 raised to the power 2. Here, therefore, we can obtain here the answer, that is 10 raised to the power 5 time. So here 1 Newton is equal to 10 raised to the power 5 dyne. Other question is, this numerical value along with the unit, if the numerical value can be anything given in the question, but if the unit or if the numerical value belongs to a constant, then it will never change. So that is, one question is there. We know that force is given by gravitational constant and product of the masses and the distance between, square of the distance between these two masses, gravitational force. Now here G, value of G is given to you in the question, which is 6.67 into 10 raised to the power minus 8 dyne centimeter square per gram square. This is given to you in the question, and you have to find, or you have to convert this gravitational constant into other system of unit, that is SI system. This system is given in C.G.S. and you have to convert it into SI. So first of all, find the formula. As we know that the unit of force is Newton, the unit of radius, that is distance, is meter square, mass is in kilogram, that is kilogram square. That is, we get Newton meter square per kilogram square. Or we can write, we know the dimensions of force, that is m1 L1 T minus 2 into L square into kilogram square. Kilogram is in mass, that is m minus 2. Now solve it, that is m minus 1 L3 T minus 2 is the dimension of gravitational constant. You can find it in rough or you can show it in a systematic manner that this is the dimension of this. Now what is our purpose? Our purpose is to find the value of its powers, that is ABC. Thus here A is equal to minus 1, B is equal to 3 and C is equal to minus 2. Here C.G.S system is given. So write C.G.S and SI. In C.G.S it is given that 9 centimeter square. M1 is given in grams, L1 is in centimeter and time is in second. And M2 is equal to in kilogram, L2 in meter and time in second. Make an equation, convert it into kg, that is 10 raised to the power minus 3 kg. It is equal to 10 raised to the power minus 2 meter and 1 second. Now substitute these values in the equation, which is equal to N2 is equal to, here we can write that N1 U1 is equal to N2 U2. Therefore N2 is equal to N1 U1 by U2. And U1 is in the form of dimensions, that is M1 by M2 raised to the power A, L1 by L2 raised to the power B, T1 by T2 raised to the power C. Substitute all these values. Here it is 6.67 into 10 raised to the power minus 8. M1 is 10 raised to the power minus 3 and M2 is 1 kg. Power is minus 1. L1 is here 10 raised to the power minus 2. L2 is 1 meter and power is 3. C is 1 by 1 raised to the power